Hello everyone, this is a session on General Aptitude for GATE 2026. In the previous session we had discussed the counting number of trailing zeros, cyclicity and unit digits. So in this session we'll discuss other topics, the remainder theorem and squares of numbers. So stay connected. First topic is remainder theorem. Remainder theorem is used to find the remainder of an expression a into b into c divided by n. Remainder of an expression a into b into c divided by n, and the remainder of this expression, that is a into b into c divided by n, is equal to remainder of the expression remainder of n into bn into cn divided by n. Remainder of the expression a into b into c divided by n is equal to remainder of the expression an into bn into cn divided by n. Now what is an, bn and cn in this expression? N is a remainder when a is divided by n. Remainder when a is divided by n. Bn is a remainder when b is divided by n. Similarly, Cn is a remainder when c is divided by n. So, this is the remainder theorem. Remainder of the expression a into b into c divided by n is equal to remainder of the expression an into bn into cn divided by n, where an, bn and cn are the remainders when a, b, c are divided by n respectively. So, we will see this theorem with the help of an example. Find the remainder of 15 into 17 into 19 divided by 7. We can use the remainder theorem, that is remainder of 15 into 17 into 19 divided by 7 will be equal to remainder of what we did in the expression n into bn into cn divided by 7, where n is 15 divided by 7. Remainder of 15 divided by 7 into remainder of 17 divided by 7 into remainder of 19 divided by 7 whole divided by 7. This is what the remainder theorem is. So, what is when 15 divided by 7, what is the remainder? When 15 is divided by 7, 15 divided by 7, 7 into 240, remainder is 1. So, this is remainder of 15 by 7 is 1 into. Now, what is remainder of 17 divided by 7? Remainder is 3. So, this is 3. Next is remainder of 19 divided by 7. This is 5. The remainder is 5. So, this is 5 whole divided by 7. Now, this is equal to remainder of 15 divided by 7. Now, we will find the remainder of 15 divided by 7. Now, we know that when 15 is divided by 7, the remainder is 1. So, the answer is 1. This is how we find the remainder of the expression 15 into 17 into 19 divided by 7. Next is polynomial theorem. This is a very powerful theorem to find the remainder of a polynomial expression. We have x plus a whole raised to n. If we expand this, how will we expand this? First term we have x raised to n. In the next term we have x raised to n minus 1. Next we have x raised to n minus 2. Then x raised to n minus 3 plus etc. X raised to 1 plus x raised to 0. Okay. Now we have NC1, this is NC2, this is NC3, here it is, etc. NC n minus 1. The last term we have NCn. Okay. Now we have one more term, that is, what is it? A raised to 1. Here it is a raised to, first term is a raised to 0, a raised to 1, a raised to 2, a raised to 3, etc. a raised to n minus 1, and the last term is a raised to n. This is how we expand x plus a whole raised to n. Okay. Now what is it? This is x raised to n plus nc1 x raised to n minus 1 a raised to 1 plus nc2 x raised to n minus 2 a square plus nc3 x raised to n minus 3 a cube plus etc. Ncn minus 1 x raised to 1 a raised to n minus 1, and the last term is, this is all 1, last term is a raised to n. This is what a plus x plus a whole raised to n. Now if we divide all these by n, x, okay, divide all these by x. So what would be the remainder of this expression? Remainder of this expression, when x plus a whole raised to n is divided by x, then what would be the remainder of this expression? This is what polynomial theorem says. And the remainder of this expression will be, see, the first term is x raised to n. When it is divided by x, it is completely divisible by x. X raised to n is completely divisible by x. So there won't be any remainder. And the second term also we have x raised to n minus 1. When it is divided by x, it is also completely divisible. Here again there is an x. When it is divided by x, this is also completely divisible. In the next term also is completely divisible. Here again x divided by x, it is also completely divisible. But here the last term, this last term do not have a x term here. So when a raised to n is divisible, divided by x, this is not completely divisible and we get a remainder here. When it is not completely divisible, then we get a remainder. Okay, so the remainder of the expression, this expression, the remainder of this expression, that is x plus a whole raised to n divided by x, will be equal to the remainder of this expression. That is, we'll write in the next slide. The remainder of the expression, remainder of x plus a whole raised to n divided by x, remainder of this expression will be equal to the remainder of the expression a raised to n divided by x, because all other terms contain an x term. Okay, rest of the terms contain x, that is completely divisible by x. Only the last term do not have an x term, therefore this will have a remainder. Okay, so this is what polynomial theorem says. So we'll see an example, that is, find the remainder of 9 whole raised to 99 divided by 8. So what you have to do here, write 9 in terms of 8. Okay, that is 8 plus 1 whole raised to 99 divided by 8. Okay, write this 9 in terms of this denominator. So what happens here, this 8 is completely divisible by 8. Okay, so when we expand this expression, that is in the form x plus a whole raised to n, we know that all other terms will contain an 8 term, contain 8. So that will be completely divisible by the denominator, and the last term only, that is 1 raised to 99, is not completely divisible by 8. So the remainder of this expression will be equal to the remainder of 9 raised to 99 divided by 8 will be equal to remainder of 1 raised to 99 divided by 8. Okay, what is this? 1 raised to 99 is 1. 1 by 8. What is the remainder of 1 divided by 8? When 1 is divided by 8, what is the remainder? Remainder is 1. Remainder will be 1. So, the answer is 1. This is how we use the remainder polynomial theorem to find the remainder. Next topic is square of numbers. Squares of numbers are frequently used for calculation of various types of problems. So first we'll write square of numbers from 1 to 10. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81 and 10 square is 100. So here we can see that the square of the numbers always ends with 0, 1, 4, 5, 6 and 9. That is, the square of the numbers ends with 0, 1, 4, 5, 6 and 9. 0, 1, 4, 5, 6, 9. And it does not ends with the numbers, does not ends with the numbers 2, 3, 7 and 8. So this is what we have to note. The square of the number never ends with 2, 3, 7 and 8. I will share you some shortcut trick to find square of any 2-digit number that is ending with 5. Shortcut for finding square of any 2-digit number that is ending with 5. First is 25. 25 square. This is a 2-digit number that is ending with 5. That is 2 plus 1, 3. 2 into 3, 6. Next is 5 square, 25. Again 35 square. 3 plus 1, 4. 4 into 3, 12. 5 square, 25. 45 square. 4 plus 1, 5. 5 into 4, 20. Last is 25. 55 square. 5 plus 1, 6. 5 into 6, 30. Last is 25. 65 square. 6 plus 1, 7. 6 into 7, 42. Then 25. 75 square. 7 plus 1, 8. 7 into 8, 56. Then 25. 85 square. 8 plus 1, 9. 8 into 9, 72. Then 25. This is how we find the square of any 2-digit number that is ending with 5. This is the shortcut method.